Hello everyone. So today in this video we will discuss about the distance traveled in nth second. In previous videos we have discussed about different topics like your velocity, acceleration, distance, displacement, uniform motion, non-uniform motion, and acceleration, average velocity, average speed. So all these concepts, and along with the concepts some numericals also we have solved in the previous videos, that is in your part 1, 2 and 3. So if you have not watched this video so far, you can go and you can watch this video. So this concept is from your chapter number 3 that we are discussing, and this is motion in a straight line. So when the object moves in a straight line, it obeys certain equations, and the equations of motions, that your v is equal to u plus at, v square minus u square equal to 2as, and s equal to ut plus half at square. These equations also we have derived in the previous videos, and using the graphical method we will derive this equation of motion again in the next video by calculus method. And first we will introduce calculus in the next video, then we will discuss or we will derive the equations of motion again using calculus method. So what we will discuss in this class? In this class we will discuss the distance traveled by an object in nth second, right? So we will discuss distance traveled by an object traveled in nth second. Okay. Or you can say s nth we are supposed to calculate. We are supposed to calculate s nth. So what is this s nth? S nth means your Sn minus Sn minus 1. What does that mean? That means suppose the object travels like this in first second, or this is your 1, 2, 3, this is your 0 and this is your 4, like this, right? So if the object starts like from 0 and 1, 2, 3, 4, so if I'll say what is the distance traveled by an object in third second. Third second means t is equal to 3 second to t is equal to 2 second. Okay, this time interval, within this time interval how far the object has moved, that is your distance traveled in third second. So what is the distance traveled in third second? The distance traveled in third second is this one. This is your s third, s nth. We are discussing about s nth, right? So your s third is distance traveled from 2 second to 3 second, that distance. That's why we are writing s nth means Sn, the distance traveled in third second, minus the distance traveled in 2 second. So that difference will give you the distance traveled in third second. The distance traveled in third second. Okay. So this is the meaning of Sn. So what is Sn? Sn formula we know. S formula, displacement formula we know. That is ut. T, time is your n, right here. Third second. 3 is your time. So n is your time here. So t will be n here, ut plus half a t square, that means n square. N is time here, minus Sn minus 1, that is ut plus half a t square equation, right? S is equal to ut plus half a t square, this equation of motion, this one we are using here. So here time is n, so as n minus 1, when time is n minus 1, that is, for example, you will just try to compare with this example. In this example it is 2, right, the previous time. So this n minus 1, when it will be when the time will be, so ut time will be n minus 1, and this will be plus half a t square n minus 1 square. Now you subtract it, just you will subtract this one and you will get a good expression for this. So what you will get, so just you simplify this, this is un plus half a n square, and if you will multiply this one, you will get this is here, what you will get, un minus u plus, this is half n minus 1 square, we will just expand it, a minus b whole square, that is n square. So 1 upon 2 a n square, right, plus 1 upon 2, 1 square is 1 a minus 2ab, so 2n into minus, so a by 2 into, this is 2n, 2 cancel out, so this is your right side, right? So what you are getting here, what you are getting here, so you see, just you better open the bracket, so this one will minus, this is plus, this is minus, and this will be minus, this will be plus, right, if you open the bracket. So un and un will get cancelled, yes, so u will be there, plus u, so u I will write, and what else is here, half a n square minus half a n square, also we can cut out. So what else is there, so this is there, this will be left out, that is plus a n minus half a n minus half a. So then if you will take a by 2 common, so this one will come up as u plus, if you will take a by 2 common, acceleration, so here it will take a by 2 common, it will be 2n, here it will be take a by 2 common, so this will be minus 1, yes. So this is your lesson, distance traveled in n second, u plus, u is the initial velocity, u plus a by 2, acceleration by 2 into 2n minus 1, n is the n second, n is the n second. So for fifth second, if you are asking, if in the question it is given that the distance traveled in fifth second is 24 meter, fifth second means, suppose this is 4 to 5, in this 4 second, in this 1 second, 4 second to 5 second, that is your fifth second, the object is, let's say, traveled 200 meter, let's say the object has traveled 200 meter in fifth second means 4 second to 5 second, okay, the object has traveled 200 meter, so this is called fifth second. So you can write that what will be n here, n will be 5, we will put n here 5, right? So let us use this one and solve one problem so that it will be clearer for you, right? Let us solve one problem. So note down the problem, all of you. So the problem is, a body covers a body covers 10 meter in second. 10 meter in, a body covers 10 meter in second. This is second, though number 2. Okay, first second, and this second is time, unit of time, second. This, a body covers 10 meter in second and 25 meter in 25 meter in fifth second. 25 meter in fifth second. If the motion is uniformly accelerated, how far will it go in 7 seconds? If the motion is uniformly accelerated, how far? I am not writing if the motion is uniformly accelerated, you can edit. How far it will go? It will go in 7 seconds. In 7 seconds. How far it will go in 7 seconds? So how will you solve this problem? Very easy. The object moves 10 meter in second. So what you will write? Second. S second is initial speed, let's say u, plus acceleration we do not know, uniformly accelerated a by 2, and your time 2n minus 1, 2 into n is here 2 minus 1. Yes, and this is equal to given 10 meter. One equation we got. The second equation is fifth second, that means s fifth is u plus, what is the distance traveled in fifth second? U plus a upon 2. Fifth second means your time is 5, n is 5 here. So 2 into 5 minus 1, that is equal to 25 meter. Now you see, important thing, here two variables, two equations are there. You can solve this by the standard procedure, you know, substitution, elimination or cross multiplication. If two variables are there or two unknown quantities are there in two equations, linear equations, you can solve it, right? So here we are having now two linear equations. We can solve them easily by using any method that known to us. So the first equation, let's say, and this is your second equation, so you can simplify and you can write that this is u plus a by 2, and this is 4 minus 1 3 equal to 10. This is one equation, this is one equation, and the second equation is u plus, this is 10 minus 1 9, so a by 2 into 9 equal to 25. So once we get u and a, we can find easily. The question is how far it will go in 7 seconds. That means s seventh we can find out easily, right? This is our target. So let us calculate that. So first solve this one. Let's say this is 3, this is equation 4. So now subtract it. Elimination, use eliminations, subtract and remove u first. Then let's see what you are getting. So u cancelled out. So you will get, this is 3a by 2 minus 9a by 2 equal to 10 minus 25. So how much you are getting here? That means you are getting, I can do here 2 LCM, 3a minus 9a you are getting, supposed to get minus 6a equal to minus 15. Yes. So now you cross multiply here. So this will give you minus 6a. This will give you minus 6a equal to minus 30. 15 into 2 is minus 30. Minus cancelled out. Your acceleration is 30 upon 6. That is your 5 meter per second square. So you are getting an acceleration that is 5 meter per second square. Now you can use your acceleration in either of the equation and you can calculate easily the initial velocity, that is u, you can calculate. So either of the equation, suppose I will use in equation number 3, then I will get, suppose from equation number 3 what I can get. So your u plus a is 5 into 3 by 2 equal to 10. So from here you can calculate u, right? So your u will be this cross multiply 10 into 2 by 5, sorry, this will be subtracted, right? So 10 minus 15 by 2, so this will is LCM 2, 20 minus 15, so this is 5 upon 2. So this is u is 5 upon 2. Yes. So once you get u and once you get u and a, you can easily find out your S7th. You can get S7th. Okay. So what is your S7th? The question is you have to find S7th. So now S7th, how will you find out? The formula is u plus 2n minus 1, n is 7 here. So u plus a by 2, u plus a by 2 into 2n minus 1, n is 7 here, minus 1, right? So u is here 5 by 2 plus a is also 5 by 2, this is 14 minus 1 is 13. So LCM is 2, this is your 5 plus 65, so 70 by 2, that is 35 meter. So in 7th second, the object, this is meter per second, 5 by 2 or 2.5 meter per second, this is your u, initial velocity. So on 7th second means this is your 6th, this is your 7, so this distance in 7th second, 6 second to 7 second, how far the object is traveled, that is the distance traveled in 7th second or nth second. So the object has covered 35 meter in its 7th second, right? So what we have discussed in this class so far? In this class we have discussed about the distance traveled by an object in its nth second, that one we have discussed in this, and also we have solved one numerical, right? And in the previous videos, as I have told you, we have derived, in the last part we have derived the equations of motion, and in the next video we are going to introduce your calculus and instantaneous velocity, instantaneous acceleration we are going to discuss. After that we will go to also one class we will keep for discussing about different graphs, so that this chapter will be completely covered, right? So just note down and practice as many problems as possible. If you have any doubts in any steps of the derivations, you just ask me in the comment box. I'll try to find some solutions video and I'll try to upload it if possible, right? Thank you for watching the video. See you in another video. Bye bye.